Tonight, we're going to the moon, and this SpaceX Falcon 9 rocket is taking us there. On board is a lunar lander that's built by Intuitive Machines. It's carrying science and technology investigations from NASA's Commercial Lunar Payload Services initiative. This will help pave the way for humanity to live and work at the moon.
Well, first off, we love her, and her name is
not?
Athena. Including her solar panels, she's just over 14 feet tall. With the landing gear, she's just shy of 15 feet wide. That's about the length of a standard car parking spot. The lunar lander weighs nearly 1,500 pounds and is capable of delivering about 220 pounds of payload to the lunar surface.
And you can see the Falcon 9 on Launch Complex 39A. Falcon 9 is a two-stage rocket, and it's the first orbital-class rocket capable of reflight. The first stage, the tallest portion of the vehicle, marked there on your screen, that provides 1.7 million pounds of thrust thanks to its 9 Merlin 1D engines.
That's right, and near the top of the second stage, powered by the Merlin vacuum engine, or MVAC, while this is very similar to the Merlin 1D on the first stage, this engine has a large nozzle which allows the second stage to perform more efficiently in the vacuum of space. Now, the first stage is what gets us out of the Earth's atmosphere and into space, and the second stage is what takes the payload to its targeted drop-off orbit. Now, that large barrel structure with the pointed nose at the very top of the vehicle is the payload fairing, and it's composed of two halves made up of carbon composite material that come together to protect the payload until we're in the vacuum of space.
Now, the Intuitive Machines landers need to be fueled on the pad with cryogenic methane and oxygen starting about 2.5 hours before launch.
Yep. And speaking of Athena, the lander arrived in Florida back in January, and since then, teams have been integrating the spacecraft to Falcon 9's second stage in preparation for launch.
One suite, which stands for Polar Resources Ice Mining Experiment. It consists of two instruments, the Trident drill, which you see right here, and a mass spectrometer called MSOLO, which you see right down here. And joining us now live to discuss these two tools is Dr. Jackie Quinn, Prime 1 Project Manager with NASA. Jackie, thanks for joining us.
Oh, thanks for having me.
So let's start with this instrument right here, the Trident drill. Can you walk us through how this works?
So actually, this is a life-size rendition of the Trident drill. So that's the exact size that we're going to send to the lunar South Pole.
Big.
Yeah, it's actually was designed and built by Honeybee Robotics. It's a percussive augering drill, and it has the ability to sample down to 1 meter depth. So that's a little over 3 feet. And the way it works is it goes down in about 4-inch sections. It'll go down 4 inches. It'll collect the lunar regolith on the flutes of the drill. It'll bring it to the surface, deposit on the surface, and then it goes down again another 4 inches and deposits. So do that sequentially until it reaches its terminal depth. One of the very cool things about the Trident drill is it has a temperature sensor in the very tip of the drill. So as we're going down, we're going to stop and take temperature measurements at different depths along the way. So we'll get the first thermal in situ readings as we traverse down. That'll be one first. And of course, it's the first robotic drill in the lunar South Pole. So very cool.
That's a couple calls from SpaceX here
Launch will abort the launch auto sequence immediately and proceeding to launch abort. At T-minus 10 seconds, launch will be hands-off and relying on automated abort criteria for the remainder of the count.
And Jackie, paired with Trident is the mass spectrometer, MSOLO. I love the name. It's the second part of Prime 1. How are we able to use the drill in concert with the mass spectrometer?
Right. So actually, I have another life-size rendition. This is MSOLO. So MSOLO is a commercially available mass spectrometer built by Infocon, which the engineers and scientists here at the Kennedy Space Center have ruggedized for use in the harsh environment of space. So the MSOLO works in tandem with Trident. When Trident brings up the soil and deposits it on the surface, the activity of depositing it gives enough energy that the frozen gas molecules that are residing on the grains of the soil actually sublimate into the vacuum of space. And when that happens, the mass spectrometer, MSOLO, is able to analyze the molecules and tell us which specific gases we're seeing and what quantity is there.
array. It's a collection of reflectors. You can also think of them as mirrors that are designed to use reflected light from an orbiting spacecraft laser to help locate landers better on the lunar surface.
Tahira, this technology requires no power to work and has been used since the Apollo era.
And now we're looking forward to a new era of lunar exploration with NASA's Commercial Lunar Payload Services initiative. Here's why we're teaming up with American companies to deliver science and technology to the lunar surface.
Our moon. It seems so close in the night sky, but getting there is really hard. But what if there was a way to change that? Only a few nations have successfully landed on the moon. As NASA sends astronauts back to the lunar surface, this time to stay, we will need to send science and technology instruments ahead of time to lay the foundation for human exploration. To make this happen, NASA is helping establish a commercial lunar economy. For the first time ever, there will be commercial delivery services to the moon. We are enabling American companies to send our payloads to the lunar surface for us. These delivery services will expand our capabilities for exploration, radically increasing the amount of science we can achieve. This high-risk, high-reward initiative will invest in and leverage the entrepreneurial spirit of American innovation to launch a commercial lunar marketplace, advancing technology and exploration for all of us. With this never-before-seen streamlined access to the moon, we will be able to make novel measurements and develop technologies that scientists have long wanted to do on the lunar surface. And as this new industry matures, this commercial delivery service for NASA and other customers could expand beyond the moon to other destinations in our solar system. And we can learn to live on another world because we are explorers.
This mission may provide the wisdom required to define how will humanity live and work on the moon.
These kind of questions, where we go from being observers of the moon to builders on the moon, this is the first step to beginning to answer those kinds of questions.
Her route to unlocking the moon's secrets follows the same path as an old friend.
Odysseus lunar lander separation confirmed.
Small engine firings refine Athena's trajectory before approaching lunar orbit.
We have to do what's called a lunar orbit insertion. It's about a 900 meter per second maneuver. It's a big burn.
In orbit, Athena checks on her payloads, including Lone Star's data center, and manages extreme heat in the light and frigid cold in darkness.
We're just going in orbit, doing the things you do with satellites. This will be very similar to what we do with our orbit and comm relay satellites, starting with IM-3.
A short engine firing sends Athena into a lower orbit to prepare for one final 600-second burn maneuver to the surface.
And it's a nice ride. The engine provides a steady level of thrust that does pick up a little bit as we deplete fuel, but we control it.
Finally, Athena's true mission, delivering technologies, science, and services that may enable humanity to live, work, and explore deeper into the solar system.
It's definitely a great feat. But once you're there, you want to expand from that landing spot and go and look at different things.
For approximately 10 days, Athena is designed to support NASA's Prime 1 drill suite, deploy a rover, send a rocket-fueled drone into a crater, and connect those spacecraft using Nokia's 4G LTE lunar surface communications system.
We have people that are driven to build and fly and operate space equipment, and that's what we're here for. It's who we are.
In a decade, Falcon 9 has supported 45 missions to the International Space Station with our Dragon spacecraft, starting with our first cargo resupply mission, then returning human spaceflight capabilities to the U.S., and even helping launch 2 additional cargo missions with Northrop Grumman's Cygnus.
Now, in the near future, Axiom plans to attach a module to the ISS. And that will eventually detach and form an independent station, one of many commercial space stations that will come online soon, as well as after the International Space Station exits service at the end of its operational life.
That's right, John. And when ready, SpaceX will help deorbit the space station. NASA awarded SpaceX a contract to develop the USD orbit vehicle, or USDV, which is a modified Dragon designed to guide the ISS through a controlled re-entry into Earth's atmosphere. This will be a pivotal moment in spaceflight history, and as the space station departs orbit and hands off the baton for future private missions, like those from Axiom or VAST, which is working on developing space stations that launch directly into orbit. And you can see that on your screen right now.
Now, SpaceX's drive to unlock space does not end there. In 2021, SpaceX launched Inspiration 4 on a 3-day journey around the Earth. It was the first all-civilian mission to space. And missions like Inspiration 4 that you can see here, Polaris Dawn, and the upcoming From 2 mission, those allow commercial astronauts to conduct research and other activities in the microgravity of outer space, as well as demonstrate new technologies while orbiting the Earth. Now, as some of you may recall, last year the Polaris Dawn crew reached the highest altitude ever in Earth orbit since the Apollo program. They participated in the first ever extravehicular activity, what we call an EVA, where they stood up in Dragon wearing SpaceX-developed EVA suits. They also conducted 36 research studies and experiments designed to advance both human health on Earth and during long-duration space flights. There's a nice view of the very top of Dragon where they conducted that EVA from in the SpaceX suits.
It's named after the award-winning NASA mathematician and computer programmer Melba Mouton, who contributed to the successful Apollo 11 moon landing. Mons Mouton is about 100 miles from the lunar South Pole, climbing nearly 20,000 feet high. That's about the height of Mount McKinley in North America. Right, for Athena tonight.
Well, both of these sites are lunar highland areas, very similar when it comes to that. The IM-2 landing site is about twice as close to the South Pole than our first mission.
Why was Mons Mouton chosen? Was there anything specific that you all used to really narrow this down for IM-2?
That's a great question. I asked our scientists, and as we move closer to the South Pole, combining Earth and Sun visibility becomes more challenging. So we chose Mons Mouton because the Sun and Earth visibility enables a longer surface mission so that NASA commercial payloads may complete their operational goals. It also has a crater close by that we're targeting for Grace to explore called Crater H,
where the Orion spacecraft is closely monitored for mission control during flight. Speaking of the Orion spacecraft, teams are gearing up for another important exercise off the coast of San Diego, California. Underway Recovery Test 12, or as we like to call it, URT-12, is the third in a series of tests to make sure teams are prepared to safely recover myself, Reed Wiseman, Victor Glover, Jeremy Hansen, and the Orion spacecraft. On URT-12, a mix of NASA and stand-in astronauts will be inside an Orion mock-up, and Navy divers will practice getting them out of the capsule and into helicopters, which will fly them to a nearby naval ship. Teams will spend the week running through different scenarios, including a daytime or a nighttime splashdown. That's your Artemis Moon Minute.
Now, when the costs are lower, government and commercial customers can launch more missions, which helps accelerate development. This also helps commercial satellite and private research customers afford to launch more projects to space, and that helps stimulate innovation here on Earth.
In the past, almost exclusively planetary exploration has been done with wheeled rovers, and that's been great. They're incredibly reliable. They do their missions well, and we've benefited greatly from them. But we've got to the point now in the science investigations, particularly on the moon, where we need to get into those more hard-to-reach places. In this case, we want to get to the bottom of a crater. We want to get into those permanently shadowed regions where we believe that resources, water, and other volatiles are there that we can go and eventually extract and use. And so a wheeled rover would be impractical to think that you could get down those steep slopes, over those cliff edges, down into those extreme temperatures, and then back up, right? So the fact that you have a hopper that can come up, over, set down nicely, do the science it needs to do, and then safely get out of there really changes the game on where we can go and do science on planetary bodies. And it's not just applicable to the moon, it has reaches out towards Mars and beyond.
All right, Mark, I'll throw you a curveball.
Sure.
Can you tell us more about another one of these tipping point initiatives with Nokia that hopes to deploy the first cellular wireless network on the moon?
This is the one that seems to just light people up when you talk about it. It's so familiar. Nokia has done such a fantastic job of taking their terrestrial telecom 4G networks that connect billions of people and devices every single day, and they're packaging it for space, and they're going to use it on future Artemis missions and future human sustained presence on the moon and Mars and beyond. And so to get a 4G network and to get that high-speed data, voice and datacom, and have your kind of local internet connecting all your devices up there really is an important part of meeting communication requirements for a human mission. So this demonstration is going to teach them a lot about what they need to do to collect that data. The environment is obviously very different. You're in a vacuum environment. The temperatures are different. The regolith's going to play. So the way the network responds will be a little bit different on the moon than here. So they need to collect that data so that they can go back and optimize their system.
Nokia's technology miniaturizes and integrates all of these components into a single network in a box.
This is Nokia Bell Labs Network in a Box that you can hold in your hands. It contains every single component that make up a 4G LTE network. Scaled down to this size, weight, and power, we could install it onto the Intuitive Machines Nova Sea lander along with specially designed antennas. Every gram that we send to the moon matters. While compact, the system also has many redundancies and fail-safes, allowing it to recover and heal itself. We also overhaul the system software to minimize the impact of ionizing radiation that would normally cause sensitive electronics to malfunction.
The network links directly to devices in both the Lunar Outpost Map Rover and Intuitive Machines Micro Nova Hopper. For the mission to succeed, this network must be fully autonomous. It must deploy and configure itself once on the lunar surface. As the lunar rover goes about conducting experiments, and the hopper goes deep within a crater, the network must also constantly make adjustments to ensure it maintains connectivity.
This is an uncrewed mission. There will be no human technician to tweak or repair the network if something goes wrong. Achieving that level of autonomy was a monumental task to undertake. Working with NASA's Space Technology Mission Directorate, Nokia plans to test the first cellular network on the moon. Success will have implications far beyond this important mission.
On the primary payloads, ride shares like the 3 additional payloads you can see, well, you can't see here, it's below the lander, but those ride shares will be helping to build the lunar economy. All these missions are something that Yomei is going to talk about.
And they're coming in flight.
Thanks, John. Yeah, all of these missions are developing our future in space and helping to support sustained human and robotic activity, including scientific research, resource extraction, and infrastructure development. Now, you should be able to see here some of today's rideshare payloads on the stack there, just below the Athena lander.
Now, NASA's Lunar Trailblazer is also hitching a ride today, and we'll learn more about that later in the webcast.
And if for any reason we do not launch today, we do have a backup opportunity tomorrow at 7:11 p.m. Eastern Time.
At this point in the countdown, both the first and second stages are nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. Falcon 9 uses 2 propellants. One's a refined form of kerosene called RP1, or Rocket Propellant 1, and we also use LOX, or liquid oxygen, as our oxidizer. Now, fire generally needs 3 elements to ignite: heat, fuel, and an oxidizing agent, in this case oxygen. That's the fire triangle. In our case, the liquid oxygen is chilled well below its boiling point. That makes it denser, and that means basically we can load more of it into the rocket.
Yep, and the third part of that fire triangle is a chemical known as TTAB, or triethyl aluminum and triethyl borane, which we use as an ignition.
Stage 1 LOX load complete.
There's that call out for stage 1 LOX load complete. And the combustion of RP1 and LOX is what makes the rocket go, and it's that TTAB mixture that sets the match to the propellant mix.
Now, in addition to finishing LOX loading on the second stage in about 30 seconds, We'll have another major event at T-minus 60 seconds, and that's Falcon 9 computers going in startup. The autonomous first and second stage internal flight computers will take over the countdown. Inside of T-minus 2 seconds, we'll light the Merlin 1D engines for liftoff. And right now, though, coming up on T-minus 2 minutes, the Intuitive Machines payload continues to be healthy, and the Falcon 9 team is tracking no issues on the rocket.
Currently, the weather is green and the range is ready to support a T0 at 7:17 p.m.
Page
Eastern
2,
Time.
lock load complete.
Okay, we've heard the call out just inside T-minus 2 minutes. Locks load on second stage complete. You can probably also hear the background enthusiasm. Everybody is getting ready for a launch to the moon. Next major event coming up right now.
Ground gas closeout.
Ground gas closeout. That means that strongback alongside the Falcon 9. We're draining any propellant from the ground lines. We're venting gas overboard. That'll also create what's typically a large white plume that comes off of the strongback. The cold, gaseous oxygen we're venting off of the strongback mixes with that warm Florida air, and you get a large white cloud, and you can see it streaming away. Waiting for the call out for startup of the flight
Falcon 9 is in startup.
You see and hear it. We're in startup. Everything looks good. We're going to get the LD go for launch. And with that, let's pause for a minute and listen to that go.
LD, go for launch.
Right on time. Always love to hear that call out. T-minus 30 seconds and counting. All systems are go for launch of Falcon 9 with the Intuitive Machines lunar payload.
T-minus 15. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff. Go Falcon, go Intuitive Machine.
Vehicle is pitching downrange.
And looking forward to the number.
Falcon 9, carrying IM-2's lunar lander Athena, has successfully lifted off at pad 39A. We're heading to the moon. We heard the call out of the pitch kick. That's a small tilt of the vehicle. We're still going pretty much straight up, but now we're also slowly heading horizontal.
You heard that call out for power and telemetry nominal, and once we reach orbital altitude, we're going pretty much horizontal to the Earth. The rocket needs to go about 17,000 miles per hour.
Falcon 9 is supersonic.
Horizontally. We heard that call out. We are supersonic, and in just a few moments, we will pass through max Q, or maximum aerodynamic pressure, on the booster.
Max Q.
We're through max Q, and the Merlin 1D engines have throttled back up to full power. Next call out we ought to hear is MVAC chill. Falcon 9 data is continuing to look good as the first stage heads out over the Atlantic Ocean. Trajectory looking good on Falcon 9. Now we're going to have a few events coming up in quick succession. We're going to start with MECO, main engine cutoff. That's the point during the flight where we shut down the 9 Merlin 1D engines on the first stage. Then we'll go into stage separation, and then SES-1, which is the second stage engine start number 1.
And shortly after MECO, stage 1 and 2 will separate from each other, with the first stage booster beginning its trip back down to Earth, while the second stage engine starts for the first time, known as SES-1, where the single Merlin vacuum engine on board the second stage will light up. This is happening in just a few seconds.
MECO.
Stage separation confirmed.
And back ignition.
Call-outs of 3 good events. You heard it, and you should have seen it there on the webcast. MECO stage SEP and SES-1. Now, the first stage is not powered. It's shut down. Great views coming from the second stage cameras as we have just had sunset a little while ago at Kennedy Space Center. The first stage is now coasting to apogee. That's the view on the left side. We're slowly turning using cold gas thrusters. We're turning to orient the engines into the direction of flight. Also, you may have been able to make out in a little bit of the light, the titanium grid fin deployment is underway. We're using pneumatic gas pressure.
Confirmed.
And here comes fairing separation. And a beautiful view. Looking at Athena and the ride shares on top of the second stage stack. So we had good fairing
Vehicles are on a
separation.
nominal trajectory.
Trajectory's nominal. First stage is looking good as it coasts to apogee. Second stage under power. Yome, everything continuing to look good right now on the mission.
Yeah, we are at just over T plus 4 minutes into today's mission. IM-2 is SpaceX's 24th launch this year, and we are currently in the first of 2 planned MVAC burns. Around the T plus 6 minute mark, you should see on your screen the first stage's entry burn. It's currently making its way back down to Earth. And for that entry burn, we will relight 3 of the M1D engines on the first stage, starting with the center engine, followed shortly by the engines next to it, which will slow down the vehicle as it passes back into the Earth's atmosphere. Now we need to slow down the first stage to reduce re-entry forces, which will help us recover and reuse that first stage. And you can follow along on your screen to the telemetry on the bottom left and right of your screen for the stage 1 and stage 2 speeds and altitudes.
Now you may have noticed on the left side of your screen, first stage altitude has begun dropping. We have reached apogee, and now we are under the pull of gravity, headed back down to the Atlantic Ocean. Now to slow us down, we'll use that entry burn. And that means we're firing 3 Merlin engines to decelerate the Falcon 9, but we'll still be moving very rapidly. And that's going to cause the vehicle to fly through the Merlin exhaust gases. It's also known as the rocket's plume. And this will deposit a layer of soot on the vehicle surface, one of the signatures of a flown booster. Now that soot comes from the carbon-based fuel that Falcon 9 uses. Now it took us almost 2 minutes since separation to get up to apogee. It's going to take the rocket just as long to bring the first stage back down to the edge of the atmosphere for the entry burn coming up in just about 20 seconds or so. Now, as a reminder, the first stage that's supporting today's mission is performing its entry burn for the 9th time. Falcon 9 is the world's first orbital reusable rocket. This is important because it's that reusability that allows SpaceX to refly the most expensive parts of the rocket, and that in turn drives down the cost of space access.
Stage 1 entry burn startup.
Stage 1 FTS is saved.
There's that call out for entry burn startup, and this will be about a 30-second burn, slowing that first stage down as it re-enters the Earth's atmosphere.
Stage 1 entry burn shutdown.
There you can see the end of that entry burn on the first stage. And on your right, you can see the second stage still in the first of 2 planned burns carrying the Intuitive Machines 2 payload to the moon. Now coming up next, we will shut down our MVAC engine on the second stage, followed quickly by the landing burn on our first stage. And the second engine cutoff of this first burn will be in just about 30 seconds at the T plus 7 minutes and 46 second mark.
Stage 2 is in terminal guidance.
You can see on your bottom right the speed of the second stage accelerating as we are in that burn.
Stage 1 transonic.
Stage 2 STS is saved.
MVAC shutdown.
There's that call out for MVAC shutdown. We should be getting a confirmation of a good orbit as
Stage
well as
1 landing burn.
there is that stage 1
Nominal
landing
parking
burn.
orbit.
And that confirmation of a good orbit on stage 2. Let's watch stage 1 come back home.
Landing leg deploy. Stage 1 landing confirmed.
Awesome views of that first stage landing. There you have it. That was the 413th recovery of an orbital class rocket, including first stage landings for Falcon 9 and Heavy.
Oh, first stage is back on the drone ship. Beautiful mission. Second stage is in the parking orbit in our low Earth orbit. Now the mission does continue in space with stage 2. Coming up next, we have the second burn of our MVAC engine. We call that SES2. And that'll be the second stage burn around the T plus 36.5 minute mark. And we'll follow that with spacecraft separation. Until then, we're going to send you back to Tahira and Josh at Kennedy Space Center.
It's the only NASA science investigation on this mission that will not land on the moon. Once it deploys, it will orbit the moon about 60 miles from the surface to help scientists better understand the lunar water cycle. It will also inform future human missions as to where supplies of water may be found and extracted as a resource. The mission is managed by NASA JPL, and its science investigations and operations are led out of Caltech University.
So the way that we're doing that, we have two state-of-the-art instruments. We have one called the high-resolution volatiles mineral mapping, mineral moon mapper, excuse me. I'm a little excited.
It's a proper government name.
Yeah. HVM cube is what we call it by. And that studies the near-infrared reflected light from the sun. So the sun shines the light onto the lunar surface, and the light that's reflected back off basically carries with it like a spectral fingerprint of where water and minerals are on the lunar surface. So we'll be measuring those, and then riding along with that is the Lunar Thermal Mapper, which is out of Oxford University in the United Kingdom, and that was supported. So it's an international partnership with the UK, and they're measuring the temperature of the lunar surface at the same time that we're measuring the spectral signature and understanding where the water is.
Now, Rachel, quickly, can you tell us how does the work that Lunar Trailblazer is intending to do lay the groundwork for what we want to do with our Artemis?
Well, so, we have these hints of water on the lunar surface in the permanently shadowed regions of the moon and also on the illuminated surface. But if we want to go there with Artemis, if we want to live off the land, if we want to use the water that's there, we need to understand where it is. We need to understand how much is there. And so Lunar Trailblazer, on a scale that people can actually operate on, will be able to map whether there's ice in the permanently shadowed regions and that kind of thing. So to help pick landing sites and see where we want to be.
Wow, that is crazy. What an exciting future. Thank you so much for joining us,
Thanks,
Rachel.
Okay. All right, thanks very much.
Now, Josh, I understand that there are a few other commercial rideshare payloads that, like Lunar Trailblazer, will deploy from the Falcon 9 rocket after Athena.
That's right, Tahira, and you can see it at home in this animation. Athena separates, and then the 3 rideshare payloads deploy. This animation has a condensed timeline. We actually expect the payloads to separate about 5 minutes after Athena.
Wow, I mean, even the animation, this is gorgeous. This is going to be such a spectacular view. So can you walk us through, what exactly is deploying here?
Well, what you're watching are all of the rideshare deployments, including Astroforge, a space mining company, using this mission to scout its target asteroid that is out of this world, and deployment of Epic Aerospace's payload called Chimera. It's an orbital transfer vehicle intended to deploy multiple payloads after separation.
And is there a special reason, that these ride shares joined Intuitive Machines CLPS lunar launches?
That's a great point. And Intuitive Machines takes an Apollo-like trajectory to the moon. It's called a translunar orbit. It's like throwing a fastball right at the moon. It enables Athena to get there in about 8 days, but for ride shares, it's an opportunity to get into a high-energy orbit to get places like the moon or a deep space asteroid like Astroforge. It's also an opportunity to send our future lunar data relay satellites on the same launches as our lander missions, starting with IM-3, which is, of course, also carrying our CLPS payloads from NASA.
That's right. And IM-3 will be Intuitive Machines' third lunar delivery mission as part of CLPS, an initiative where NASA and American companies have teamed up to explore the moon. Now, a lot of research needs to happen before humanity can live and work on the lunar surface. And these CLPS missions are like our stepping stones towards creating that sustainable future. In the end, the rewards outweigh the risks.
Landing on the moon is hard. We're going back. Under this Artemis program, we're going to be sending humans to the moon for the first time since Apollo. So ahead of humans, we want to get up as much science, exploration, and technology experiments as possible.
So CLPS starts facilitating a lot of the early science, the things we want to learn before we even send humans. CLPS stands for Commercial Lunar Payload Services, CLPS.
The services part is the key element. Ordinarily, when NASA delivers a payload to the surface of the moon, they do it with a commercial partner, but NASA controls the building of the vehicle. Now, we're buying the service of delivery of our lunar payloads to the surface of the moon.
It is a delivery service, akin to a delivery service that you'd have here on Earth.
NASA will provide payloads to a commercial company. They decide how to get it to the moon. They have to develop their own lander, but they also have to manage the entire end-to-end mission.
It's meant to provide affordable, rapid, frequent access to the lunar surface through American companies.
We're funding different companies.
We have commercial companies that are competing to win task orders to deliver our payloads to the surface of the moon.
One of the goals when we started CLPS was to help establish a lunar economy.
Somebody has to do it first, and then it becomes commercially available. Then they're able to crank them up. Then they're able to make it more affordable. And so the lunar surface is just the next frontier for a commercial environment.
But we had to acknowledge up front, all the way through the highest levels of the agency leadership, that some of them will fail. These missions may not be as successful as a traditional NASA mission.
We have accepted the risk that going through this innovative approach with these commercial companies, that there could be some failures. Some of them are new companies. None of them have ever successfully landed on the surface of the moon. So they're going to learn lessons.
We need to give our vendors the opportunity to learn.
And so that'll help ultimately buy down our risk as these companies learn, okay, what does it take to actually build up the lunar lander, integrate payloads, get to the lunar surface and land safely?
They've been able to demonstrate that they have very, very good technical depth and the ability to design and execute missions. We're willing to take more shots on goal. We aren't risking human lives. And in the big picture, if we're flying missions at 1/10 of the cost of a NASA mission and we fail 2 of them, we still get 8 missions for that same price.
Even with 1 or 2 or 3 failures, this is still a very economical proposition. It's a risk posture which is more risk tolerant than NASA is accustomed to. There's not a single one of these companies that's willing to bet their mission on a coin toss. Every one of them is doing what they can in order to have the most successful mission possible. But the important thing to realize is that risk tolerant does not mean risky. And the rewards are a long-term ability to get payloads to the moon inexpensively, frequently, and rapidly.
We want science, so we can then put more of our resources on even more science, exploration, and technology payloads and get more of a return on investment when we get to the moon.
CLPS provides tremendous benefit across the scientific and economic communities.
So there's a lot we'd like to learn about the moon to help human habitation and prepare us for missions to Mars and beyond.
So the moon is the first step.
Becoming the first commercial company to land and operate on the surface of the moon.
Houston, Odysseus has found his new home.
And rapidly advancing services for lunar data transmission and infrastructure.
When we jumped off on this CLPS initiative and pivoted the company towards the moon, it pushed the boundaries of what could be possible, and so we thought unconventionally.
Last fall, we continued development of our lunar terrain vehicle, the Moon Racer, wrapped up 2024 with NASA astronaut testing at Johnson Space Center, along with a meteor crater trial run in Winslow, Arizona. To support delivering Moonracer and other heavy cargo, the company completed several milestones in developing its heavy cargo lunar lander, Nova D.
So what we're able to do with heavier cargo is provide a logistics supply chain to the moon.
And while 2025 starts with another lunar liftoff, development of the first lunar data relay constellation capable of 4K video transmission is underway to support Artemis missions to the moon.
Starting with our third and fourth CLPS deliveries, we plan on deploying data relay satellites and begin operational capability for Artemis and allow for more robust communication from the surface.
Each mission is building the foundation for a sustainable presence on the moon and a foothold toward the next step into the solar system.
MVAC ignition.
That's the call out for MVAC ignition. It's always cool to see that MVAC nozzle start glowing in the middle of the burn. We are about 30 seconds into our 60-second planned burn on the second stage, carrying Athena and the rideshare payloads to the moon.
MVAC shutdown.
There is that call out for MVAC shutdown. We've completed that second burn of the second stage. Just waiting on confirmation.
Nominal orbit insertion.
There is that confirmation for a good orbit, and it looks like we are on track for spacecraft separation in just a few minutes.
It's been a great launch so far. Coming up 38 minutes since we had the liftoff. And now we're waiting for that IM-2 lander to separate from Falcon 9's second stage. A little bit of a recap while we're waiting for that. That comes in a little under 6 minutes from now. We had an on-time liftoff shortly before 7:16 p.m. Eastern Standard Time from Launch Complex 39A at Kennedy Space Center. Everything has proceeded nominally. 2.5 minutes into flight, we got stage separation. We also saw the successful landing of Falcon 9's first stage on our drone ship, a short fall of gravitas, and that made the 9th landing for this first stage. Now, about T plus 7 minutes, 46 seconds, we had a successful second stage engine cutoff, SECO 1, and we heard the call out of a good parking orbit insertion. Now, that was the first of 2 burns of the second stage engine, and we just saw the second burn of that engine complete. And we also are in a good transfer orbit right now. Pay attention on the bottom right to the altimeter. We didn't change altitude very much during the 1-minute burn, but you can see we're starting to move away from Earth now. Now the vehicle is coasting at this point in time. Payloads are still attached as we're counting down towards the separation of the Athena lander. Now currently the second stage is in a coast phase, as I mentioned. We are essentially making sure everything is quiescent on the stage. We're venting down pressures. We're making sure that overboard vents are done so that nothing, for example, burps during flight. We want Athena, when we send the separation command from the flight computer, to just be moved away with the power of the springs and not have any jostling if, say, the second stage inadvertently vented something at that time. So we're making sure everything is quiet on the second stage. Now we're coming up, we're under 4 minutes to separation, and we're getting great views of the second stage as it prepares to separate the IM-2 lander to begin its 8-day journey to the moon. And of course, given the way spacecraft want to be oriented to the sun, for example, to make sure when they separate, they get power onto solar cells. If you're wondering why we have a camera pointed right at the sun, well, that's a requirement of the customer to make sure that the spacecraft gets nice and warm, gets a lot of power, everything looks good. And we talked about the 8-day journey to the moon. The Athena lander is carrying science and technology investigations from CLPS that will help pave the way for humans to live and work at the moon. And today's mission is the second CLPS mission for Intuitive Machines. Now we're waiting right now, separation coming up a little under 3 minutes. Getting some more views. We're cycling, the flight computer is cycling between the various cameras on stage 2. Got a view of the nozzle. As we heard earlier in the broadcast, that'll make a large maneuver as they get to the moon. But right now, everything is quiet on the lunar lander. Here's a view of the nozzle extension one side. Here's the other camera at the back end of the second stage. The silver blanket that you see there, that's multi-layer insulation. We put that over the back end. That keeps all the valves underneath and the electronics warm and cool. Warm from the chill of darkness and the vacuum of space, and also helps insulate it from the hot radiative plume when we fire that second stage engine.
Got some cool views of the sunrise on the coming up from the Earth's horizon over there, which is very cool. Very cool to see.
"42 minutes, everything continues to be nominal on the second stage. Now, just to give you an idea of where we've been, where we're going, in about 1 minute, we are going to get deployment of Intuitive Machines 2 lunar lander, named Athena. We had the launch. We got into orbit with the first burn of the engine you see there on the screen. We just finished the second burn about 5 minutes ago, and we are in a coast phase on stage 2, making sure everything on the stage is quiet, do final vents, and then make sure that the stage is very stable, it's not moving around. And then we'll see deployment. It'll be interesting. I'm not sure which camera views we're going to get at deployment. Now, once we do the deployment, we then start another sequence that takes about 3 minutes and 50 seconds, and then we will get to the rideshare deployments. We'll have one, and then every 20 seconds, and then 20 seconds after that. Right now, we're just counting down, waiting for deployment. So let's listen into the countdown net.
There is that deployment. You can see IM-2 Nova C lunar lander named Athena floating away from Falcon 9's second stage, confirming spacecraft separation. Now, from all of us here at SpaceX, we are wishing the IM-2 lander a good flight and safe travels. SpaceX is honored to be a part of NASA's Commercial Lunar Payload Services Initiative to deliver science and technology to the lunar surface, and we thank NASA and the Intuitive Machines for entrusting us with today's historic mission to the moon. Now, while we wait for the next development, let's bring in Tahira and Josh back at KSC.
Yo, man, that was absolutely gorgeous. What an excellent throw from SpaceX. Tahira, what do you think of that shot?
It is unreal, literally. It's so gorgeous.
Right now, we're going to continue to listen in simultaneously. We have Intuitive Machines Nova Control in Houston, Texas. That's going to be waiting for acquisition of signal. That's Athena's first call home, while also monitoring SpaceX.
FM, can you call out when we should have booted? And then if we get close to Confetter, give us a call.
All right, that's Intuitive Machines Mission Control
Athena
confirming
separation confirmed.
Athena separation confirmed. And Tahira, while we stand by and keep running this clock for about 5 minutes after launch vehicle separation, that's when we expect Athena to make that first call home. At the same time, John I and Yomei in Hawthorne, California will be calling out those ride-share deployments.
And Com and Raven, let's tell on screen. Scuba to stand by, and let's focus on Singapore and T-Knot.
Yep, on screen you're looking at Intuitive Machines Nova Control on the left, and you're looking at the second stage views on the right with SpaceX, Tahira.
Just gorgeous views. Look at that Earth. That's us.
Absolutely incredible. A lot of things are happening right now. It's a very dynamic situation where Athena's preparing to make that first call home. We're counting out the time that since Athena has separated, and that's because at launch vehicle separation, Athena starts a countdown to when she can power
says
on.
1 minute 47 is the earliest time for transmit. We are at 1 minute 55.
All right.
Copy.
1 minute 55 here. Let's go ahead and pause and listen into the loops here as we listen to Intuitive Machines
Granite,
Mission
keep
Control.
active comm. Give us anything you got from the ground station.
As well as SpaceX and Hawthorne waiting for those rideshare deployments. Let's just listen in here.
AD permission back to TMAC for a second.
Here we go.
Those calls you just heard are the ground net stations that you're looking at right now inside of Nova Control, waiting for the ground stations on Earth to acquire Athena's signal. We're standing by in Houston for Athena making that first call home, standing by in SpaceX Hawthorne for waiting for those 3 rideshare deployments. We expect all of these things to be happening simultaneously.
And Josh, right now from Hawthorne, we should be about 30 seconds away from starting that sequence of rideshare deploy. First up should be Astroforge's Odin. 20 seconds after that, Lunar Trailblazer. And then 20 seconds after that, Epic's Chimera. Odin deployed, as you heard over the net.
Status, Odin's away.
Lunar Trailblazer, separation confirmed.
Lunar Trailblazer away.
We heard the call out in the acknowledgement. Lunar Trailblazer separated. Wait about another 10 seconds, and it'll be Chimera.
Yeah, we will have an OEM for them. Priority right now is Singapore.
Chimera away.
Understood.
All spacecraft are separated.
4 minutes 15 seconds past that.
All right.
Now Josh Tahira. Falcon 9 second stage has sent its commands. Everything successfully deployed. Now we're waiting a word from you all on acquisition of signal from Athena.
Thanks a lot, John. We're still listening in to Intuitive Machines' Nova Control.
I am status waiting for 1909 for our window to open for visibility on the first station.
That's flight controllers waiting for that window to start listening in for Athena to make that call home. We're just about inside of that expected window for her to make that first call, Tahira. We expect Athena.
We're still standing by for connection with TNOC, is that correct?
That's good feedback.
I'm getting.
Should I enable randomization?
Yeah, we're getting some information. We're waiting for visibility at our first ground station to hear. Those are the large radio astronomy dishes on Earth that are needed to make that connection to Athena out in space. What she's doing right now is autonomously commissioning. That's a process where she's turning on her power systems, getting into max power attitude. That's pointing that top deck solar array right at the sun, making sure we're getting good power coming through. Again, I'm just getting a little bit of information here that the visibility of the first station, that first ground station, to make that connection with Athena, 1909. So probably here just in the next couple of minutes, Mission Control is just going to be standing by for that opportunity. Until that window comes,
6 minutes post-up.
We're not going to hear that confirmation until that ground station's ready to receive that signal.
Now, Josh,
Copy that.
what
Com,
happened?
we're expecting 1909 for the visibility.
That's correct.
That's It's 1909. They're talking in Central Time, so that's 8:07 here on the East Coast. So here, just a couple minutes away, flight controllers are watching their screens, waiting to make that first connection with Athena while she's been autonomously commissioning herself in space. That process of getting to max power attitude, getting her radio pairs on, and making that first call home, all while moving just about 24,000 miles per hour.
She's doing a lot.
That's right.
Now, Josh, what happens if Athena exceeds that time window?
Well, if Athena exceeds that time window, it's okay. She's also programmed to swap radios and antenna pairs to get in a better configuration to make first contact with flight controllers that your folks at home are watching on the left side of your screen. That's Nova Control in Houston, Texas.
Seven minutes, 25 seconds past set.
Copy that.
That's 7 minutes and 25 seconds since we watched
We are
Athena
halfway
separate.
to trip and fitter.
I understand. We should be getting a call shortly from TNOC to connect.
All right, that's a good call from our activity director. That's John Graves, waiting for our ground station to connect to Athena as we continue to watch video from the second stage. That's SpaceX on the right and Intuitive Machines on the left. We'll see, what time do we have here? About 8:08 p.m. Eastern Standard. We're standing by for the ground stations on Earth to receive the signal that we expect. Athena is ready and already making that call back through that autonomous commissioning process. Tahira, you touched on what happens if we don't make this connection. It's going to be all right.
It's okay. Okay, good.
And we heard a call from Mission Control talking about a comm fitter being halfway through its cycle. What they're talking about there, Tahira, when we say it'll be okay, it's starting.
Back to me, Goose. Ground out, what are we seeing? Is T not giving you any feedback? Come while they're working that. When is visibility open for Okinawa?
1:29. All right, so we're listening in to when those ground stations will have coverage to connect with Athena in space.
What about DSS 34?
Let's go ahead and toss it back to John and Yome in Hawthorne, California.
In 5 minutes.
We are 9 minutes, 30 seconds past set.
Copy that.
And FM.
Oh, thanks,
15
Josh.
minutes and it just swaps towers, right?
Now we're hearing comms in the background right now.
7, 6, 5, 4, 3, 2, 1. Ignition and liftoff. Go Falcon, go Intuitive Machine.
Vehicle is pitching downrange.
M1D propulsion is nominal.